Assalamu alaikum everyone. My name is Muhammad Umar and my member name is Saima Sadiq. I am here to present my presentation on the topic of depth first search belonging from the course of Algorithm Graph Theory teaching by Dr. Mujibur Rahman. First of all, we will see what is depth first search. Depth first search is an algorithm for traversing or searching tree or graph data structures. The algorithm starts at the root node, selecting some arbitrary node as the root node in the case of graph, and explore as far as possible along each branch before backtracking. So the basic idea is to start from the root or any arbitrary node and mark the node and move to the adjacent unmarked node. Continue this loop until there is no unmarked adjacent node left behind. Then backtrack and check for other unmarked nodes and traverse them. Finally, print the node in the path. We will understand what is an algorithm. The algorithm of depth first search is super simple and super easy. You have to follow just simple three ways. First, create a recursive function that takes the index of node and a visited array. Mark the correct node as visited and print the node. Traverse all the adjacent and unmarked nodes and call the recursive function with the index of adjacent node. Let's understand the depth first search with an example. In the example, we will see how the depth first search algorithm works with an example. We use an undirected graph with 5 vertices. We will start from the root node, which is 0. The depth first algorithm starts by putting it in the visited list and putting all of its adjacent vertices into the stack. So when we are traversing the 0 node, the adjacent nodes 1, 2, 3 is put it into the stack. The order of putting vertices in the stack depends upon what kind of searching you are performing. It is pre-order, in-order, or post-order. Next, we visit the element at the top of the stack, 1, and go to its adjacent node. Since 0 has already been visited, we visit 2 instead. Vertex 2 has an unvisited adjacent vertex in 4. So we add that to the top of the stack and visit it. Vertex 2 has unvisited adjacent vertex in 4, so we add that to the top of the stack and visit as I already stated. After we visit the last element 3, it doesn't have any unvisited adjacent node, so we have completed the depth first traversal of the algorithm. Here is another example of depth first search in which we start from the root node 1. When we are traversing or visiting the root node 1, the adjacent node 2 and 3 are put it into the stack. When we are moving to the top of the item of the stack, which is node 2, the adjacent node 4 and 5 are put into the stack. On observing the root node 4, there is no unvisited nodes left behind, so backtracking is possible and we will go to another node 5. The same case is with 5. We doesn't have any other unvisited node in that, so we will further backtrack and move to the one left unvisited node, which is 3. Let's see the pseudocode of the depth first search. The pseudocode for depth first search is shown below. In the initialization function, notice that we run the depth first search function on every node. This is because the graph might have 2 different disconnected parts. So to make sure that we cover every vertex, we can also run the depth first search algorithm on every node. Let's see the complexity analysis. First, we will discuss the time complexity, which mainly depends upon vertices and edges. Space complexity is an extra visited array is needed of size v, so its space complexity is O of v. Here are some applications of depth first search. It is used for detecting a cycle in a graph. What is cycle in a graph? A graph has a cycle if and only if we see a back edge during depth first search. So we can run depth first search for the graph and check for back edges. It can be also used for path finding. We can specialize the depth first search algorithm to find a path between two given vertices u and z. It can be any vertices. Topological sorting is mainly used for scheduling jobs from the given dependencies among jobs. In computer science, applications of this type arise in instruction scheduling, ordering of formula cell evaluation when recomputing formula values in spreadsheets. Logic synthesis determining the order of the compilation task to perform in makefiles, data serialization, and resolving symbol dependencies in linkers. It can be also used to test if a graph is bipartite or not. We can augment either BFS or depth first search when we first discover a new vertex. Color it, opposite it, parents, and for each other edge check it doesn't link two vertices of the same color. The first vertex in any connected component can be red or black. Finding strongly connected component of a graph. A directed graph is called strongly connected if there is a path from each vertex in the graph to every other vertex. So depth first search algorithm can also be used to find strongly connected components of a graph. It can also be used for solving puzzles with only one solution, such as mazes. Depth first search can be adopted to find all solutions to a maze by only including nodes on the current path in the visited set. So that's all from the depth first search. I hope you like it.